SklearnisotonicIsotonicRegression. Description: Isotonic regression is a non-parametric regression model in scikit-learn that enforces monotonicity on the predicted output. This means that the predicted values must either always increase or always decrease as the input values increase. Inputs: X. The input features independent variables. It can be a one-dimensional array or a two-dimensional array where each row represents an observation and each column represents a feature. Y. The target values dependent variables. It must be a one-dimensional array. Outputs: Y. The predicted target values. It is a one-dimensional array of the same length as Y. Isotonic. The fitted isotonic function. It is a one-dimensional array that represents the fitted relationship between the input values and the predicted target values. Steps: The model first calculates the cumulative sum of the input values. Then, it calculates the cumulative sum of the target values. Using a pool-adjacent Violatus-Bow algorithm, it finds the optimal monotonic relationship between the cumulative sums of the input and target values. Metrics: R-squared, a measure of how well the model fits the data. It ranges from 0 to 1, with 1 indicating a perfect fit. Mean squared error MSE, a measure of the average squared difference between the predicted values and the actual values. Visualization plots: Scatter plot, a scatter plot of the input values against the predicted target values. This plot can help visualize the monotonicity of the fitted relationship. Fine-tune parameters: Y min, the minimum value of the predicted target values. Y max, the maximum value of the predicted target values. Increasing, a Boolean flag that indicates whether the fitted relationship should be increasing or decreasing. Out of bounds, a string that specifies how to handle out of bounds input values. Uncertainty methods: Bootstrap resampling, the model can be fit multiple times on different bootstrap samples of A data to estimate the uncertainty in the predicted values. Confidence intervals: the model can be used to calculate confidence intervals for the predicted values. Challenges and fixes. Challenge 1: Overfitting to noisy data. Sample use case that resulted in challenge 1: If the data is very noisy, the model may overfit to the noise and produce a highly non-smooth relationship between the input values and the predicted target values. Fixes to challenge 1: Use a smoothing technique, such as a moving average, to smooth the input values before fitting the model. Use a regularization parameter to penalize model complexity. Challenge 2: Handling outliers. Sample use case that resulted in challenge 2: Outliers can significantly affect the fitted relationship. Fixes to challenge 2: Remove outliers from the data before fitting the model. Use a robust regression technique, such as the Thales-Sane estimator, which is less sensitive to outliers.